For commissioning of the measurement program, a not yet hemmed car body is needed. When manually moving the hemming head robot to the 3 implemented measurement positions and performing the acquisition, it can be checked in the automation interface window if the measurement values have been transferred correctly. To open the automation interface windows for hemming head and hemming bed, double-click on the folder symbol right to it in the project tree. For every measurement performed, a transfer time should appear in the automation interface view. Check the measured profiles in the associated measurement views and adjust the measurement regions and exposure time if necessary. For every successful measurement, a green tick will appear in the associated line of the project tree. Once all 3 measurements have been performed, the result is calculated when the getResultFrame command is fired by the robot. The calculated result can be seen in the automation interface view. If the calculated result is within its tolerances before and after correction, the associated part line, in the video it is part G05, will also get a green tick. If it is not within the tolerances for every measuring point before and after correction can be adjusted by expanding the project tree. Now you can go on with the hemming bed robot. Run the program on the hemming bed robot until it waits for the digital input of the head robot. Hem _DI correction applied. Next, run the measurement program on the head robot until it waits for the digital input of the hemming bed robot. Hem _DI correction applied. Continue on the hemming bed robot until it starts moving. Check the messages on the robots to make sure that both applied the same correction. Also compare the getFrame result in both automation interfaces for hemming head robot and hemming bed robot. Now continue on the hemming bed robot and teach the optimal aligning position of the hemming bed on the car body.